All right, so machine learning algorithms, huh? Bet you're hearing that everywhere these days.
Definitely seems like it's a hot topic right now, but tons of folks want to know more.
They want to know what's the big deal. Why all the fuss?
Right.
Well,
And I think what's really cool is how many places these things are popping up.
you see them everywhere, but most people don't really get what they are.
Right.
So let's take a deep dive into this, shall we?
Absolutely.
We found this awesome guide that breaks down these machine learning algorithms into 4 types.
Yeah, this is a great way to think about it.
It's a great way to think about it, and we'll go through them.
And we'll kind of compare it to how humans learn.
Exactly. It's
Oh,
like they mirror different ways we learn ourselves.
Right.
Which I think is fascinating.
It is.
Okay, so first up, supervised learning.
Right.
Now imagine you've got this textbook, and it's got all the answers in the back.
All the answers laid out right there for you.
The algorithm's kind of like that student who's peeking at the answers, right?
Yeah, it's like having a teacher right there with you, too, showing you this is how you do it.
Exactly. It's given the input and the desired output. And then it uses that knowledge to make predictions on new stuff, things it hasn't seen before.
So you show it a bunch of examples and it starts to see the patterns.
It starts to see the patterns.
And then can apply that.
So think about predicting house prices. The bigger the house, generally the higher the price.
Yeah.
That's a pretty straightforward relationship, right?
Yeah, a pretty simple relationship. That's a great example for linear regression, which is one of these supervised learning algorithms.
Right. And so linear regression is great when you've got a situation where the bigger something is, the more it costs or whatever it is you're measuring.
Exactly. Finding that relationship.
But what about when you need to figure out something like, is this email spam or not?
Okay. Yeah. A little more complex. You can't just look at the size of the email.
Exactly. A simple, like, bigger means more expensive won't work there.
Huh.
What do you use in that kind of situation?
Right. So that's where we'd pull in something like logistic regression. And that's really good for those classification problems.
So you're putting things into categories.
Putting things into categories, exactly. So is it spam or not spam? That's a classic example.
Gotcha. So is it this or is it that?
Exactly. Or let's say you're trying to figure out, should I wear a jacket today? We've got this other algorithm for that called decision trees.
Decision trees. Okay.
And it's kind of like you were saying with the textbook, having all the answers. It's like a flow chart.
Okay.
You know, it goes through the steps. Okay, so what's the temperature outside? Is it raining? And it kind of goes through this tree of decisions to get to the answer.
Interesting. So it's breaking the decision down into smaller yes-no steps.
Exactly.
Very cool. Now, we can't talk about supervised learning without mentioning neural networks, right?
Oh, yeah, you can't avoid them these days.
They seem to be everywhere. They're often touted as these like super powerful algorithms, almost like a magic solution sometimes. What's the real story with neural networks?
Yeah, and they're really good at certain things, like image recognition. They've really revolutionized that field.
You know, being able to identify a cat in a picture or a dog in a picture, that kind of thing.
Exactly. Or, facial recognition is another big one.
Yeah, I mean, those are things that until very recently, computers were absolutely terrible at. But now they're exceeding humans in some cases. It's kind of wild.
Yeah, but they're also really complex. It's kind of like a black box.
What do you mean by that?
We don't always know exactly how it arrived at its conclusion.
It just gives an answer.
You feed it tons of data, it learns those patterns, and then it gives you an output.
And we don't always know how it got there.
Right, which can be a little unsettling.
A little unsettling, yeah. Especially when you're making decisions that affect people's lives. You want to know how you got there.
Absolutely.
So, okay, we've covered supervised learning. Let's move on to unsupervised learning. What's the difference?
Okay, so this time, no textbook, no answers.
Ooh, challenging.
Very challenging. Imagine you're giving that puzzle, but there's no picture on the box.
So you're just looking at these pieces and trying to figure out how they fit together.
Exactly. That's what these algorithms have to do. So there's no labels, no guidance. It's all about finding patterns in the data.
So I give you a bunch of data about customers and their buying habits.
Yeah.
An unsupervised learning algorithm could go through that and find patterns that we wouldn't necessarily see as humans.
Exactly. That's a perfect example. And that's where something like k-means clustering comes in.
K-means clustering.
It basically takes your data and tries to group it into clusters based on similarities.
So it would look at all these customers, their buying habits, their demographics, and group them together based on shared characteristics.
Yeah, and that could be really helpful for things like targeted advertising.
Right, so if you know this group of people tends to buy these kinds of products, then you can target your ads more effectively. Makes sense from a business perspective, but from a consumer perspective, I can see how that could feel a little creepy.
Right, there are definitely privacy and ethical concerns there.
Absolutely. It's important to think about those things. Okay, so K-means clustering is one way to do unsupervised learning. What are some other techniques?
Okay, well, there's another really cool one called principal component analysis.
Principal component analysis. What a mouthful.
Yeah, it's a bit of a mouthful, but we usually just call it PCA.
PCA, okay?
So think about having like a giant textbook that's just overwhelming.
Thousands of pages,
Hmm.
tiny print, the kind.
Exactly. PCA is like taking that giant textbook and creating a really concise summary.
So it's pulling out the most important information.
Yeah, it helps to reduce the complexity while still capturing the essence of the data.
That's brilliant, especially in today's world where we're just bombarded with data. It's like drinking from a fire hose.
It is, it is. And PCA can be really helpful in all sorts of fields, from genetics to finance.
Very cool. All right, so we've got supervised and unsupervised learning. What else is there?
Well, we've also got this kind of in-between approach
In between. Okay.
called semi-supervised learning.
Semi-supervised. What does that mean?
So imagine this. You've got a little bit of labeled data, but you've got a ton of unlabeled data.
You've got a few pieces of the puzzle put together,
Exactly.
but the vast majority of the pieces are just scattered all over the table.
Right, and this happens a lot in the real world because labeling data can be expensive.
It can be really time-consuming, too.
Right, you got to get humans involved to actually look at the data and label it.
And humans are expensive.
They are expensive, they're slow. So in those cases, semi-supervised learning can be really helpful.
So it's like using the small amount of labeled data to guide you as you work with the rest of the unlabeled stuff.
Exactly. So you use what you know to try to make sense of what you don't know.
Gotcha. Are there specific methods used within semi-supervised learning?
Yeah, there are. One that's really interesting is called label propagation.
Label propagation.
Okay. Imagine a social network, right? And a few people's political affiliation.
Okay, I follow.
Label propagation can use those known affiliations and the network's structure to predict other people's affiliations.
So you're using the relationships between people to fill in the blanks.
Exactly. It's kind of like assuming that birds of a feather flock together.
Makes sense?
Yeah,
So you're using what you know to make educated guesses about what you don't know.
right.
That's pretty cool.
Right.
Okay, we've covered 3 types of machine learning algorithms. What's the 4th one?
All right, so last but not least, we have reinforcement learning.
Reinforcement learning. Okay.
This one's kind of like training a dog with treats. You reward them when they do something good. You maybe scold them a little bit when they do something bad.
I know that feeling. I've got 2 dogs myself.
Oh, yeah.
Yeah. So the algorithm is basically learning through trial and error.
Exactly. It tries different things. If it gets
Okay.
a reward, it's like, okay, I'm going to do more of that. If it gets penalized, it's like, okay, maybe not that.
So you're not telling it exactly what to do. You're just setting up a system of rewards and punishments.
Right. You're letting it explore and figure out what works best.
That's cool. Those videos of robots learning to walk, they always start off so clumsy, but eventually they get it right.
Exactly. That's
Yeah.
a great example of reinforcement learning in action.
And it feels very human, right? Because we learn so much through trial and error, too.
Definitely. Think about learning to ride a bike. You fall a bunch of times, but eventually you figure it out.
And it's not like someone's standing there telling you exactly how to balance. It's more about getting a feel for it yourself.
Right. You get that feedback, you adjust, you improve.
Very cool. So what are some specific algorithms used in reinforcement learning?
One of the most popular ones is called Q learning.
Q learning.
Yeah. It essentially helps the algorithm learn which actions are best in different situations.
So it builds up this knowledge base of what works and what doesn't.
Exactly. Like in that robot learning to walk example, it's figuring out which movements will keep it upright and which ones will make it fall.
Okay, that makes sense. Now, I've heard of deep Q networks. How do those fit in?
Ah, yes. Deep Q networks, or DQNs, they're super interesting.
Okay, so it's like Q learning on steroids.
Basically, they combine Q learning with deep learning, which we talked about earlier.
Right, that super powerful black box approach.
Exactly. And by combining them, you get this really powerful algorithm that can handle even more complex situations.
So things like self-driving cars or playing games like Go, where there are millions of possible moves.
Yeah, situations that are way too complicated for traditional Q learning.
Fascinating. It's pretty mind-blowing when you think about how deeply these algorithms are already woven into our lives.
Right. It's crazy. I mean, we're talking everything from personalized medicine to fraud detection. They're working behind the scenes in so many areas.
And it's only going to get more prevalent, right? As these algorithms become more sophisticated, they're going to be used in even more ways, which is exciting, but also a little bit daunting.
Absolutely. There are definitely ethical considerations we need to think about.
For sure. Hmm. But it also makes you wonder, what's next? What are the big breakthroughs that are just around the corner waiting to be unlocked by machine learning? It's an exciting time to be alive, that's for sure.
It is. It is.
Well, that's all the time we have for today's deep dive. But if you want to learn more about machine learning algorithms, be sure to check out the show notes. We've got some fantastic resources there to help you continue your exploration.
Absolutely. Happy learning.
Happy learning.